Look out into the deepest pockets of space, and you will eventually find a black hole. They are the apex consumers of the universe, aggressively feeding on any starlight or rogue debris that drifts too close. Their entire mechanical identity is built around a single, inescapable well of gravity. It is a pull so dense and absolute that it crushes entire solar systems down to a single point. We have spent decades observing and modeling this extreme form of cosmic consumption, but that focus leaves us blind to the exact opposite extreme lurking out in the void. That opposite force is known as a white hole. Instead of pulling matter inward, it violently expels energy outward at the speed of light. It is a perfect mechanical inversion. If a black hole is an infinite cosmic drain, the white hole is an unending geyser. You might assume that pushing things away makes it a safer neighbor, but that outward blast makes the white hole severely destructive. Anything caught in the path of that energy is instantly obliterated, which sets up a fascinating thought experiment. What actually happens if an unstoppable force of outward expulsion physically collides with an inescapable well of gravity? To understand the fight, we have to look at the fighters, starting with a massive age gap. Our white hole is a veteran wanderer that has survived for millions of years. This timeline illustrates a leading theory. The white hole is the evolutionary end state of an ancient black hole. After millions of years of hoarding mass, it reaches a tipping point, giving back everything it consumed, blasting that matter back into space. So, our collision features an up-and-coming, gravity-heavy black hole drifting directly into the path of this ancient, expelling white hole. Because their mechanics are strict opposites, it's easy to assume they would just cancel each other out in a quick flash of light. Instead, they lock into an agonizing struggle that lasts for millennia. This schematic shows why the battle takes so long. As the spheres meet, the white hole's only defense is radiating a massive wall of energy outward. But the black hole's unyielding gravity simply bends that radiation directly into its intake funnel. It is a cruel mechanical irony. Because the black hole is compelled to consume, the white hole is effectively force-feeding its attacker. Every ounce of matter the white hole ejects to defend its territory is seamlessly swallowed and converted into fuel for the black hole. The white hole is trapped in a fatal paradox. The harder it fights to survive, the larger and more inescapable its enemy becomes. This one-sided feeding frenzy continues for thousands of years until the black hole finally reaches critical mass, completely swallowing the exhausted white hole. This merger triggers an exponential surge in mass, forging a single bloated predator. This photograph shows the glowing ring of Messier 87, measuring roughly 38 billion kilometers across. Our theoretical victor could easily reach this staggering scale, and we know this scale is a reality. As you can see in this photograph of the Event Horizon Telescope research team, scientists have actively documented and measured these apex predators out in the wild. To truly comprehend what an anomaly 38 billion kilometers wide looks like, look at this diagram. That massive black void represents the new black hole, and that microscopic blue speck is our entire planet. Looking at this full-view photograph of Earth, the math is sobering. A post-collision black hole would be roughly 3 million times larger than our home. In these extreme environments, opposing forces rarely find a peaceful equilibrium. Instead, they compound. They feed off of each other, birthing colossal anomalies that go on to violently consume and reshape everything in their path.